This video covers the spring final review for algebra, problems 41 through 50. Before we start that, a couple quick reminders. The review is due before you start the test, and the review is worth 10 bonus points on the final. So for problem 41, we're working on this. These answers came from a previous video for 31 through 40. So 41 asks for the domain of the function h. Domain for all quadratics is always all reals. The only time your function will not have a domain of all reals is when you're given something with endpoints or very specific pieces. But any function that is linear, quadratic, or exponential will have a domain of all reals. The range, on the other hand, is a little different. The range is your y values. Your y values are at 9 and go down from there. So y and 9 are related. Because your y's are getting less than or lower than 9, we use a less than sign. But your y's could be 9 because that's where our vertex is, so we put the line under the inequality sign to include it. The roots of the function are where the function crosses the x-axis. It crosses at -5 and +1. So my roots are -5 and +1. Remember the word exercise? Sorry, I don't know how to spell. But the word exercise helps us remember the x-intercepts, roots, solutions, and zeros all mean where it crosses the x-axis. Now, problem 44 has a plus by it because anything with the plus can be done in the calculator. 44 asks which function best represents h, and they give us some A, B, C, D answer choices. So what I'm going to do is plug in my answer choices and see which one matches that graph. If I'm not sure if it matches exactly, I'm going to use the table to check for points. This is A, and I can see A is not in the same spot because this is my origin right here. My graph is more to the left in the picture, but this one is more to the right. Option B has a minus instead. Option B looks very similar. Let me double check. Option C, well, this is option D. D is very clearly not right because it's upside down. And C is not right because it's also upside down. So B would be my answer. 45 asks how the function of y equals x squared plus 3 would be affected if it were changed to 2x squared minus 7. So what I'm going to do is plug these into y1 and y2. And when they pop in, the one that is that pops in first is my first option. The one that pops in second is my second option. My calculator goes really, really quickly, so I'm actually going to use this one because it's color-coded. I don't think this one is. Oh yeah, this one's color-coded. So x squared plus 3 in y1 and 2x squared minus 7 in y2. So this is going into y1. And this is going into y2. Again, on your calculator, the way that it pops in will be the way that you put it in. On mine, blue will be first, red will be second. So see, they come in kind of quickly. So that was the first one. That was the second one. So we can see that it would shift from blue to red. It would shift down. And it would be a change of 10 units. Because it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can also see, it's kind of hard to see, but we can also see that this blue one looks fatter than the red one. So the red one compared to the blue one got skinnier or narrower. So for 45, it's going to shift down 10 and it will be narrower. Again, these are things that you can know just by knowing the changes in your quadratics. However, you can also plug them all in and see what would happen. Problem 46 is asking another question about how do these graphs relate to each other. So in y1, I'm going to put x plus 8 squared. And in y2, I'm going to put x minus 4 squared. So y1 and y2. I'm putting them in exactly like I see them, and I press graph. I'm going from blue to red. So from blue to red moves over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units to the right. So it moves 12 to the right from the first one to the second one. 47 says, compared to the graph of the parent function, the graph of y equals 1/4 x squared plus 6 is. So first thing I need to remember is that the parent function is y equals x squared. So in y1, I'm just going to put x squared so I have a visual to compare it to. In y2, I'm going to put this in exactly like I see it. I have 1/4 x squared plus 6. So blue compared to red. Blue is my original, red is my new. Looking at the blue, it shifted up 6. And the red got wider. Or sometimes we say was stretched. Okay. Problem 48. They ask me how the graphs of f of x and g of x relate to each other. So f of x is what I'm going to put into y1. So that's the x squared plus 9. And in y2, I'm going to put g of x. So x squared minus 11. Blue is first, red is second. So on my graph, blue is first, red is second. So I can see from the blue to the red, red was the second one. So g of x is going to move down. And I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 11 more would be 20 comparatively. Now it's hard for us to see whether or not it got skinnier or fatter, so for that I'm going to go back to the original, and I have x squared and x squared, which means that it's not changing any wider or narrowerness. 49 asks us to write a function in vertex form for the graph shown. So vertex form is a x minus h squared plus k. That's our normal vertex form, where h comma k is the vertex. So my vertex is here at -3, -1. So I'm going to plug that in. X minus -3 minus 1. Now we know that minus minus is plus. And the only other thing I need to do is see if I have a stretch or shrink. So from the vertex, it goes out 1, up 2. 1, 2. Normally it goes out 1, up 1, but this goes up 2, which means that it's going to have a stretch of 2 in front of it. If I'm not sure, or if I'm given answer choices that look like this and I want to see if I'm right, I can go back to my original one that's a little bit bigger. I would plug in exactly what I just wrote, 2 parentheses x plus 3 squared minus 1. And when I click graph, I'm going to see if that graph matches the graph on my paper. If it doesn't, I might have messed up somewhere, either forgetting to put in a negative or forgetting the minus a negative, something like that. But if it does work, then I know I did it correctly. And problem 50 says, what steps transform the graph of f of x equals x squared to h of x, which is 4 parentheses x minus 2 squared plus 7. So in y1, I'm going to put f of x, which is x squared. In y2, I'm going to put 4 parentheses x minus 2 close parentheses squared plus 7. So exactly what I have. This is in y1 and in y2. So blue to red. So from the blue, I can see that my vertex moved to the right 2 and up 7. So it goes right 2, up 7. And then I can also see that the red is a lot skinnier than the blue. And so it's going to be narrower by the factor in front, which is 4. So it goes right 2, up 7, and is more narrow by a factor of 4, or narrow by 4. You could also see something like stretched by 4.